We are going to learn how to generate a YACC specification for a few syntactic categories. Specifically, we will implement a program that recognizes valid arithmetic expressions using the operator addition, subtraction, multiplication, and division in the compiler design laboratory. Now open Oracle VirtualBox and click the arrow next to the Start button to begin. Check the installed version of Bison and Flux. If they are not available, install the required software packages. Bison and Flux are software tool and they are available as packages in Linux distribution like Ubuntu and Fedora that you can install through package managers. Bison is a parser generator like YACC. It reads a grammar file .y and generates C code to pass input according to the grammar. Flux fast lexical analyzer. It is a lexical analyzer generator like lex and read a pattern file .l and generate C code to tokenize input. We have a different text editor Nano, Vim, Gedit. Nano is a terminal-based text editor in Unix or Linux operating system. It is easy to use, especially for beginners. You use Nano to create or edit text file directly from the terminal. Other alternative text editors are Vim and Gedit. Here I am using Nano editor followed by name of the file expr.y. .y is the file extension for YACC program. This program is written using lexical analyzer and YACC, yet another compiler, a parser generator. It is used to recognize a valid arithmetic expressions entered by the user, which can include operators, addition, subtraction, multiplication, division, and numeric values, that is integer or decimal. The program consists of two files. One is that YACC file and another one lex file. YACC file which define program rules and parsing logic, whereas lex file which define a token and how to recognize input like number and operators. Coming to the YACC file, percentage open bracket till the part percentage close bracket is the C declaration section. The header file hash include stdio.h includes standard input output function like printf and scanf. In the second header file, hash include stdlib.h provides utility functions like a to f, that is ASCII to float. Into YYLex function tells YACC that function named YYLex will be defined in the lex file for scanning input. Next, void YY error of const character *s is a function that handles syntax errors. Hash define YYS type double. It tells YACC that all values handled in expression like number will be of type double, useful for handling both integer and floating point numbers. Next, this portion is token and operator precedence declaration. Percentage token num. It declares num as token that represents numeric values. Example 3, 4, 5. Left plus minus. It declares addition and subtraction as left associative operator with the lowest precedence. Next, percentage left star division declares multiplication and division as left associative operator with the highest precedence than addition and subtraction. Next part is going to be a grammar rule or syntax rule. Here, input is the start symbol. It can be empty or consist of one or more lines. This allows multiple expression to be evaluated line by line. Next, line represents a single line of input expr/n. If a valid expression is followed by a new line, we print valid. /n. If only a new line is entered, it is ignored. That is blank line. Error /n. If the expression has a syntax error, print invalid and reset with this function. This defines how to parse arithmetic expressions. Num is a single number. Expression plus expression, two expression combined with addition. Similarly, subtraction, multiplication and division. $1 plus $3, it refers to the left and right parts of the expression. $S represent the result of the current row. Similarly, subtraction, multiplication and division. This is the main function that starts parsing using YY-parse. YY error is a custom error message function used when an invalid expression is detected. After finished your coding, press Ctrl plus O to save the file name or write output, then enter to confirm file name and press Ctrl plus X to exit the editor. Next, lex file, that is lexical analyzer, text editor nano followed by file name.l. In this coding, percentage open bracket till the part percentage close bracket include the header file generated by Bison, that is expr.tab.h, which defines token types like number and standard input, output and utility headers included. In this section, first line matches the integer and floating point numbers, converts input text to float using A to F and assigns to YY val. Next, it matches operator or new line and return them. /t, it matches space or tabs and ignores them. Dot any other character is returned as it is, that is fallback. And last function name YY return 1. It indicates the end of the input. Returning 1 means no more input. After completed your coding, press Ctrl plus O to save the file name. Then enter to confirm file name and Ctrl plus X to exit the editor. Now compile and run the program. First give Bison space -d space followed by YACC file name expr.y. This command runs Bison parser generator like YACC on the file name expr.y. It generates the parser code in C and header file. Bison runs the Bison parser generator tool. -d creates a header file expr.tab.h containing the token definition used by Flux. expr.y, your Bison grammar file. It contains the grammar rules and actions. So Bison -d expr.y, this line generates expr.tab.c, the actual C code for the parser, expr.tab.h, the header file with the token definition needed by Flux. To compile the lex file, give Flux followed by expr.l. This command runs Flux, the lexical analyzer generator, on the file expr.l. Flux, it means runs the Flux lexical analyzer generator expr.l. Your lex source file contains pattern and action to match tokens. This line generates lex.yy.c C source file with the generated lexical analyzer, that is scanner. It uses expr.tab.h file from Bison to match token name consistently. Next command gcc space expr.tab.c space lex.yy.c space -o space parser space -lm. This command compiles the generated C file from Bison and Flux using GCC, the GNU compiler. Here, GCC means GNU compiler collection to compile C file, expr.tab.c, parser code from Bison. Next, lex.yy.c, scanner code from Flux. -o parser, name of the output executable as parser. -lm, it links the math library. If you are using the function like power, square root, etc., that's why we are giving math library. Finally, give the command .parser. It runs the compiled parser program, your combined lexer and parser file. Now you are able to enter the expression or input which will be tokenized by Flux and parsed by Bison. Here /, it tells the cell to execute the program in the current directory. Parser, the compiled executable name from the GCC. Now press the enter button and give the valid expression. 8 plus 9 is valid. 9 star 5 valid. 4 plus plus 2 is not valid. 6 star 3 is not valid. I hope you all understood how to recognize valid arithmetic expressions using YACC specification. If you have any doubts or facing any issues while installing Bison or Flux packages or have questions about the program, feel free to leave a comment in the comment section. If you found the video helpful, kindly subscribe to my channel and press the bell icon for more videos. Thank you.